Hello students, again I am here to deliver the lecture for CSC 2 for the subject Engineering Mathematics 2. Okay, so students, as I told you in my previous lectures also that we have completed with our syllabus. So the lectures that I am delivering you people in these days, it is just a revision lectures for you. I'm just revising you the syllabus which I have already discussed with you. These are the very important topics which we have already discussed. So again students, if you feel any kind of doubt during these revision lectures even, so you can ask me. Okay, so first of all I will highlight firstly what we have discussed in the previous lecture, in my previous revision lecture, and what we are going to discuss right now. Okay, in the previous lecture I have discussed that what is a large sample. The sample in statistics having observations greater than 30, it is considered as the large sample. But the sample having the small quantity, like small quantity here we mean the sample observations are less than 30, they are considered as the small sample. And always keep remember, we are going to discuss so many tests. One of them is that for the large sample, that is when the sample size is greater than 30, then we use the Z test, okay, which is also known as large sample test. And if the sample size is less than 30, then we use the T test, F test, chi-square test as the application of the question is there. Okay, so yes, last time we have also discussed the large sample, the statistic we have also discussed for the large sample, that was Z statistic. Okay, so we have also discussed one of the application, that was mean, to check the difference of single mean or the difference of means of two samples. Right now I am also discussing the applications for the large sample test, but here the further application that I am going to discuss is that to test the significance of simple or single standard deviation or the significance of difference of standard deviations. Okay, so for testing the significance of simple or single standard deviation, that is whether the sample which we have taken from the population, whether that population possessing that particular standard deviation or not. Similarly, the difference between, or the another application which can be asked for the Z test is that whether there is a significant difference between the standard deviations of the two samples. Okay, so first of all students, I am going to tell you the formula or the Z statistic that we used during this application. So that for the test of significance of single or simple standard deviation, we use the Z statistic as Z is equal to small s minus sigma over under root 2n, where small s means the sample standard deviation, that is the sample that we have taken, its standard deviation, and sigma stands for the population standard deviation, and n is the sample size. Okay, and if I want to test the significance of difference of standard deviation of two samples or two populations, then we use the Z statistic as s1 minus s2 over under root sigma 1 square over 2n1 plus sigma 2 square over 2n2. Now what is small s1? Small s1 stands for standard deviation of sample 1, small s2 stands for standard deviation of sample 2, n1 stands for size of sample 1, n2 stands for size of sample 2, sigma 1 square is the variance of sample 1, and sigma 2 square is the variance of sample 2. Okay, so these are the students' formulas for the Z statistic. So the formula, these are basically the formula. Now I am going to discuss the applications, or I will clear the concept by the applications or by the numericals. Okay, so the numerical that I am going to discuss is that, first of all, we are having the example. Let us read its statement firstly. Is it likely that a sample of 300 items with a standard deviation 5.4 in a random sample from a large population whose mean is 16.8 and the standard deviation is 5.2. So we are having a sample whose size is 300. So 300 is greater than 30. So this sample is considered as the large sample. So definitely we can apply the Z test. So let us see its application right now. Question is a sample of 300 items and its sample standard deviation small s is 5.4, n is 300, is a random sample from a large population whose mean is 16.8 mu and standard deviation is 5.2, that is sigma. So we just want to check whether the sample of 300 items having standard deviation 5.4, whether it has been derived from that population whose mean is 16.8 and standard deviation is 5.2. Okay, so this is the numerical. So what we have given, we are having n is equal to 300, small s is 5.4, mu is 16.8 and sigma is equals to 5.2. So as our first initial step for testing is that to set up the null hypothesis. So the null hypothesis is sigma is 5.2, that is we are assuming or we are giving the consent that the sample of 300 items, it has been derived from that population whose mean is 16.8 and standard deviation is 5.2. So the alternative hypothesis is sigma is not equal to 5.2, that is the sample which has been taken from the population, it doesn't possess the mean 16.8 and standard deviation 5.2. Okay, so here I am going to use a Z statistic because the sample size is greater than 30, it is of size 300. So I will use the Z statistics, and the formula for Z statistics is S minus sigma over sigma under root 2n. So the value of S is 5.4, sigma is 5.2 and n is 300. So students, please verify this calculation. The value comes to be 0.942. Now it's time to calculate the table value. So again students, if the level of significance is mentioned in the question, you have to follow that, but if it has not been mentioned, then the choice is yours. You can take either 1% level of significance or 5% level of significance. So at 5% level of significance, the table value is 1.96. Now it is a time to make the comparison between the calculated value and the table value. Since the calculated value is less than the table value, therefore null hypothesis is accepted. It means our assumption is correct, that is the sample, it has been taken from that population who is possessing the mean is 16.8 and the standard deviation is 5.2. Okay, so here let us discuss the another application of the Z test. Okay, so let us read the statement firstly. The statement is that random samples drawn from the two countries gave the following data related to the heights of adult males. So we are having the data of two countries A and B. Their mean is given to us 67.42, the mean of heights of adult males, and then it is for country B it is 67.25. Then the standard deviation for country A is 2.58 and for country B it is 2.50. And the size of the two samples is given to you 1000 and 1200. As the sample size is 1000 and 1200, which is very much far away from 30, so it is considered as the large sample. Okay, so the question is the difference between the standard deviation is significant or not? Okay, so students, first of all, the sample size is, one of the sample size is 1000 and the another sample is having the observations 1200. So it is a question of large sample test. Moreover, we have to check the difference between the standard deviation of the two samples, whether it is significant or not. So it means we will apply over here the Z test, because one of the application of Z test is also to check the difference of the standard deviation of two samples. Okay, so what we have given, let us see firstly. We are having N1 and N2, they are the sizes of two samples, that is 1000 and 1200 respectively. Then their standard deviation, small s1 is 2.58 and small s2 is 2.50. And the means are x1 bar is 67.42 and x2 bar is 67.25. As our first step is to set up the null hypothesis, we are taking sigma 1 is equal to sigma 2. That is, there is no significant difference between the standard deviation of the two samples. Second step is to set up the alternative hypothesis, that is the statement which is complementary or which is opposite to the null hypothesis, that is sigma 1 square. Sigma 1 is not equal to sigma 2, means there is a significant difference between the standard deviation of the two samples. Now what is the Z statistics for this? As we have discussed the formula with you recently, small s1 minus s2 over under root s1 square over 2n1 plus s2 square over 2n2. So I am here putting the values of s1, s2, n1 and n2, and after calculating Please students verify the calculation whether it comes to be 1.03 or not. Okay, now it's time to conclude the table value. Again students, if the level of significance is mentioned, it's okay, but if it is not given, you can, it's twice as well, you can take either 1% or 5%. So at 5% level of significance, the table value is 1.96. The another thing which you have to keep in your mind, whenever you make the comparison of calculated value and the table value, you have to make the comparison of absolute calculated value, because the calculated value can come up with the negative sign also. So at that time we have to ignore the minus sign. Okay, or we can say this, we have to take its absolute value, that is we have to take its modulus value. So always make comparison of the absolute calculated value and the table value. So fortunately students, here the calculated is turning up with the positive sign. So I am making the comparison of 1.03 and 1.96, that is the absolute calculated value with the table value. So the calculated value is 1.03 and the table value is 1.96. It means our null hypothesis is accepted. Now what is our null hypothesis? We have taken sigma 1 is equal to sigma 2. That is, there is no significant difference between the standard deviation of the two samples. Okay, so hope so this example is also clear to you. So students, in short, again I am telling you, first of all we are just revising over here the z-test, and z-test is the another name for the large sample test, and in statistics we consider the sample whose size is greater than 30. Even there are 31 items in the sample, that will be considered as the small is greater than 30, that will be considered as the large sample. So in that case we cannot apply t-test, f-test or chi-square test. Okay, so the another application is going to first, then we have to check its application. So in various applications, two applications we have discussed in the previous lecture, that was related to the mean, that is the significance difference between the means of two samples or a single mean. And secondly, the same thing I have discussed for the large sample, that is the standard deviation, that is application related to standard deviation. If I want to check whether the sample, there is a significance difference between the standard deviation of the two samples, or the sample which we have taken, it has been taken from that population whose standard deviation is particularly that one, then we make use of the z-test. Okay, so there are other two applications of z-test also, which I will discuss with you later on in my next lecture, and that application is related with the population proportion. That is, if I want to check the single population proportion or the difference of the two population proportions, then we also make use of the z-test. That application I will discuss with you in my next lecture, and after that we will be starting with the another applications like t-test, chi-square test, f-test, which are very important from examination point of view. So these lectures are just for your revision lectures. So still you find any kind of doubt during these lectures, please don't hesitate and ask your query whenever you want through my mail, or you can call me also, and you can WhatsApp your query also. Okay, so hope so. And students, there are much more questions in the book for practice, so please solve them with pen and paper. Don't read only, please solve them thoroughly, and if you feel any kind of doubt, please ask me. So these are the applications which are widely used, not only for your academic purpose, but whenever you will do some survey, statistics, or you will do some research, they will be very helpful from that point of view also. Okay, so please be attentive regarding these applications. Thank you so much.